Yeah, any other questions from the Excel file I circulated?
No, sir.
No? Okay. So next topic then we'll start. Yeah. You completely understood the simple regression.
Yes, sir.
Do you know how to prepare what do you call ANOVA? How to make forecast? All these you understood?
Yes, sir.
Good. Okay. Fine. Then we close all these files. Are you able to see the file that I'm sharing?
Yes, sir. But like now it's visible.
Mm.
Sir, the file that you have shared was the previous example only, no, that we solved in the class.
I think yes. Just a minute. Hmm. Yeah. Yesterday we solved this, right?
Yes, sir.
Hmm. No doubts from this, correct?
No, sir, no doubt.
Okay, good. Mm, then what about adjusted R square? How do you get adjusted R square? Let us go to this. Yes. There is some column. This is the column adjusted R square. How do you get this adjusted R square? What is the value of adjusted R square?
So 0.73.
Ah. You know that adjusted R square is always less than or equal to this R square. Always adjusted R square is less than or equal to R square. Okay. But how do you get this? Do you have this MS value here? Do
So
you have
are
this
we
MS value?
supposed to give attendance right now?
No, no, no. I will randomly I will take during the class sometime.
Okay, everyone is giving, that's
Why people are giving attendance? I didn't ask you. Okay, I will show it. Anyhow, please note that the attendance that you give is not the attendance. I randomly ask you to give the attendance. That should be the attendance. Okay, fine. Anyhow, I closed it. Ah. Coming to this, Can you calculate this MS value? Can any one of you calculate this and tell me what is this? Make it fast. Do you know or not? Do you know this value or not? Array, you are not answering my question. Do you know how to calculate this total MS total? Am I audible?
Yes, sir.
Yes, sir.
But if
Yes,
you
sir.
don't respond, how do I
By
know?
adding it, sir.
Okay. You are calculating it?
Yes,
Yes,
sir.
sir.
Okay. What happened? This is very simple calculation.
So 611.08.
How you got that?
The regression plus presided.
Uh, I just write here this plus this. Is it right?
Yes, sir. 611.08.
Okay, fine. How you got this MS?
Sir, SS divided by degree of freedoms.
How about this?
Same, sir.
Okay, very good. Now my question is, imagine this is A by B. This is C by D. Suppose, okay, Control X. Yes. Do you understand what I have written?
What do you understand from this? Huh? Answer. Am I audible?
Yes, sir.
Yes.
Okay. Okay. Then tell me what this is. This correct?
Sir, is there a question mark in the equation itself?
Yeah, I'm asking, is it equal or otherwise? I'll put this question mark here. Okay, just a minute. I put the question mark here. Yeah, now you answer.
No, sir.
Why? Who answered this 611 just now? Same man has to answer this question also. Who answered this? Arey, you have to answer immediately. Otherwise, it's wastage of time. We cannot spend that much time on these simple concepts. They are not difficult at all. Damn simple concepts. Come on, come on, come on. A by B plus C by D, is it equal to this? Who answered earlier this one? Satyajit, you answered.
No, sir.
Rajat Kapoor, you?
Yes, sir. I answered it, but
Who said
I don't know about this, sir. Not sure.
611? You said, right?
Yes,
Tell,
611.08.
yeah. Rajat, tell me, is this expression correct?
Sir, I don't think so. Not sure though.
If you have any doubt, no, you can try with numbers and answer this.
Just a second, sir.
Yeah, you can answer.
They are not equal, sir.
Not equal.
No, sir.
Then how come this can be equal then? Arre, arre, arre. Okay. Then what about this? How you answered this 611 here?
Sir, as in total mean squared. So that's how we did.
No.
No.
What do you say? If this is correct, then this will be correct. If this expression is wrong, this expression is also wrong. Because exactly the same thing I asked you to calculate. Are you getting?
Yes, sir. Sir.
Exactly the same thing I asked you to do. Then tell me correct answer.
Sir, it's 108.
How you got this?
So 756 divided by 7.
Perfect. That's it. That is the correct answer. You should not add. Total doesn't mean that you simply add everything. These are ratios already. Okay? Never sum the ratios, and the sum of the ratios will not be equal to the ratio of the sums. This is what the expression I have given. Understood?
Yes, sir.
What
Yes.
this expression is? The sum of the ratios is never equal to ratio of the sums. So this is 108. Okay. How you got the regression sum of squares? I'm sorry, R square. What is the formula for R square?
SSR by SST, sir.
R
SSR by
square
TSS.
equal to SSR by TSS, correct?
Yes, sir.
Okay. Suppose, for example, you don't know this value. Suppose you don't know this value. Array. Are you able to see it properly?
No, sir.
Okay. Suppose this value is not known. Then in that case, if you know these two values only, then how do you write?
Sir, 1 minus SSC by TSS.
Very good. 1 minute. 1 minus
SSC by TSS.
SSE by TSS. Correct? Array, what is this? I'll put a, yeah. Is that fine now?
Yes, sir.
Yes,
Ah,
that's visible.
okay. Now, if I replace the same thing, I replace control V. Instead of SS, I take MS. And here also, I take MST. MST means you know what is MST, correct? What is MST value?
108.
108. MST value?
28.98.
Very good. You calculate and tell me what this value is.
0.732.
1 minute. Equal to 1 minus, I asked you to do this one, MS divided by this, I'm sorry. How much you got?
0.732.
0.7?
3167, sir.
Compare this one with this one. Same answer, no?
Yes, sir.
Yes, sir.
Okay. So then you understood how to calculate adjusted R square?
Yes, sir.
Very good. This is how you calculate adjusted R square. Okay?
Yes, sir.
Well, that's it. Okay? Now, um, okay, in simple linear regression, how many independent variables will be there?
1.
And sir.
So, okay, I'll do one thing. Close this. I will share a different screen. Just a second. Uh, just a minute. I think I have shared this one and discussed. Just look at this. I've done this.
Sir, it's not visible.
It's not visible.
Not visible yet.
Yes, sir, now it is.
Now we can see.
Yes, sir, we did this.
1 second. 1 second. Let it come properly. Is it visible? Are you able to see the screen? I think it's coming. Coming?
Yes, sir. Yes, sir.
Very
Yes,
Visible.
good.
sir.
Okay, fine. Uh, I think we have done this problem, and also we have done this. Remember? We have done this, no?
Yes, sir, we done this.
Okay, and R square is also known as what?
Coefficient of determination, sir.
Yes.
Correct. And we have done ANOVA, and what is the hypothesis? All these things you remember?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good, good. Actually, model is not significant, you take in H naught. Model is significant, you take in HA. But in symbolically, beta 1 equal to 0, beta 1 not equal to 0. Beta 1 0, beta 1 not equal to 0. And you know F value, F test, everything you know. Correct?
So sir,
Okay.
while writing statements in H naught, we will write it is significant or not
Not significant, Baba, not. Not. Not significant. That is, model is useless. There is no model. That is the kind of meaning you get from that statement. No model. Okay. Look, I just write here. Suppose, where is my pointer? Ah. Suppose y equal to beta naught plus beta 1 x. Of course, error will be there. What is the formula for beta 1? Some formula is there. But for beta naught, what is the formula?
y bar minus b1x.
Y bar minus beta 1 x bar. Correct?
Yes, sir.
Very good. Suppose, for example, you know that if beta 1 not equal to 0, then the model will be like this. Correct? Whereas
Yes.
this is beta naught. If at all beta 1 equal to 0, and suppose this is beta naught, then how the model would be?
No model, sir.
Straight line.
Only
Okay,
y
Line parallel to
first
x-axis.
y-axis.
parallel to
X-axis.
x-axis and the value is at
B naught.
Y bar.
very good. It is constant, no change For this x value, same y value. For this x value, same y value. For this, same y value. But if beta 1 equal to 0, what happens to this?
It will
Beta
be
not is
equals
equal
to
to
y
y
bar.
bar.
Beta not equal to y bar. That means average is going to be the value prediction for any x. Correct? For any x, sorry, for any x, y bar is the prediction. Correct or not?
Yes, sir.
Yes, sir.
Is it a prediction first of all? Is there any prediction?
No, sir.
No prediction. Simply you are giving y bar as your prediction. So that means there is no model, isn't it?
Yes, sir.
There is no model in this example. So therefore, there is no model if at all beta 1 equal to 0. And whatever the model you are writing like this is not significant. That is significant means it is useless. No, not significant means useless. Significant means useful. So therefore, H naught implies H naught is B1 equal to 0 means no model. Correct?
Yes, sir.
No model. No model or not a significant model, not a significant model, etc. So many meanings like this. Is it right?
Yes, sir.
Very good. And alternatively, HA is beta 1 not equal to 0. What do you mean by that? Beta 1 not equal to 0 means this one. If this is the situation, there is a model and for every x you have different y value. That means you have some prediction, correct?
Yes, sir.
But here there is no prediction. Every time you say y bar. Every time you say y bar. Correct? So there is no prediction. Hence, that is the reason in null hypothesis here the model is insignificant, not significant. And model is significant. Model is significant means beta 1 not equal to 0. I already gave you the diagram. Model is significant means beta 1 is equal to 0. Beta 1 not equal to 0. Model is insignificant, that is not significant means beta 1 equal to 0. That is, there is no slope at all. Beta 1 equal to 0 means no slope, right? Is it right or not?
Yes, sir.
Yes, sir.
Good. So beta 1 equal to 0 means no, there is slope like this. Beta 1 equal to 0 means no slope and no model.
Sir,
And yeah.
sir, it means earlier question, it means that our model is significant, right? Okay, sir.
Our model is significant only when you reject H0.
Yes, sir.
Only when you reject H0. Okay? If at all this particular one, the table value is 7.57. Our calculated value is 74.24. So don't you reject H0?
Okay, sir.
Correct? Okay, is it right? Fine. Fine. 1 minute. Mm. Okay, I am sharing another file. Please look at this. Are you able to see?
Yes, sir.
Yes, sir.
Okay, just a second. Very good. Now, can you build a model for this problem? Can you build a model? Can you?
No, I don't know, sir.
Huh?
But sir, there are three variables.
It's a multiple regression, sir. Two independent variables.
No,
Definitely, you cannot fit simple linear regression because there are three variables. When can you fit simple regression? Only when there are two variables, correct? When there are two variables, one variable is independent, other variable is dependent, correct?
Yes, sir.
Sir,
But in this case, you cannot predict, you cannot fit simple linear regression. You have to try
multiple
multiple linear
regression.
regression, isn't it?
Sir, do we have to compare, like making two models and which one is the best?
Uh, no, no. First of all, you cannot fit simple linear regression to this model. How can you compare?
Effect of TV ad on the revenue one model and print ad
No, no, no,
on
no,
the
no, no,
revenue.
no, 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 no. We are not going to try such kind of things here. Okay, we are not going to. Fine. First of all, there are three variables, and we have to make predictions. Tell me which variable can be predicted in this. First of all, which variable can be used for prediction? Because you get data like this without any information. You have to find out the variable that can be predicted.
Revenue.
Sir, the revenue.
Revenue, sir.
Everybody agrees with revenue.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Everyone agrees with revenue, right? So revenue should be predicted. The variable that you predict is known as what variable? Dependent or
Dependent.
independent?
Dependent.
Dependent variable. Then TV advertisement expenditure and print ad expenditure can be treated as
Independent variables.
Independent variable.
independent variables. With logic, can you say that they are independent? With logic, that means can you say there is a cause and effect relation between these two? So what I want to tell you is, um, I'll write the variables here. Control C, Control V. Uh, do you say that this will affect revenue and yes? Do you say
Yes, sir.
Yes, sir.
Yes, sir.
is it valid?
Yes, sir.
Yes, sir.
Yes, sir.
TV ad will influence revenue. Print ad also will influence revenue. Do you agree with this statement?
Yes, sir.
Yes, sir.
Yes, sir.
So, if that is the case, these are the causes for the effect. if you spend, cause means if you spend little more on TV ad, that effect will be observed in revenue. Correct? Is it so?
Yes, sir.
Good, good. So, and also if you spend more on this, you find effect in revenue. Is this also okay?
Yes, sir.
Yes, sir.
Good. So that implies there is a cause and effect relation between these two. Is it right?
Yes, sir.
Yes, sir.
There is a cause and effect relation between them. Cause, effect. The effect is revenue, cause is this. And in regression, you are trying such kind of causal models. Cause and effect models, or if at all there is some cause and effect kind of relation, then only you can build a model and use it for regression. Otherwise, you cannot use it for regression. If there does not exist any cause and effect relation, what is the use of building a model and using it? Do you understand what my logic here is?
Yes, sir.
Okay? Fine. So therefore, you must have cause and effect between variables. So you already answered that revenue is a dependent variable, and these two variables are independent variables. Fine.
Yes, sir.
Good. Now our problem is, definitely if at all you build any model, I write the model here. What are the model you build? That model should be, 1 minute, what is the font size? 16. I'll make uniformly 16. Okay. I write revenue equal to beta naught plus beta 1 times one of the independent variable, that is TV ad plus beta 2, because there are two independent variables. I cannot use one variable. Print ad and plus, of course, error. Is not this model for suitable for this kind of data? Is
Yes,
not
sir.
this model a suitable model for this data?
It is.
Yes, sir.
Then our problem is to find, to estimate, rather estimate, what to estimate? Is it right?
Yes, sir.
You have to estimate beta naught, beta 1, beta 2. These three values you have to estimate. How to estimate? Again, same procedure, that is principle of what is it known as? Principle of what is the method that we use to estimate parameters in regression? Forgot. Principle of least squares. Now do you remember?
Yes, sir.
What happened? Now if you don't respond now, I think that you are not with me. I lost connection. because I'm seeing only this. Okay. Ah. So beta naught, beta 1, beta 2 should be estimated using the principle of least squares, right? Okay. Then can you do you have formula for this? Even if you know the formula, by hearting the formula is going to be very difficult. Very difficult. We will not use formula to estimate this. Then what is the alternative? The only software solution. Software solution. Okay. So just a minute. Huh? Why do you see standard color something is patch is coming here?
Yes, sir.
Oh, why it's not going? Okay, I just close and open it again. Minimize and open. You are not getting. Okay,
Sir,
no
it's
gone.
fine now.
Gone now. Okay, fine. Uh, right. How to get the solution for this problem? I remove all this stuff not required. Okay.
Okay, sir.
Okay. Fine. Then in that case, go to. I do the same thing on R programming also. Don't worry about this. We are going to do again with R. Okay. Um, Go to data analysis, regression, then the input variable is y range. Y range is dependent variable, that is y. And coming to input, these two are inputs, correct? And you have labels in the first row. And where do I want output? Output I want here. Where? I want in L1. Click OK. Let me increase the font size. Okay, so right, this is the output. Use your calculator and answer my questions. What is square root of 0.41?
0.640.
There is a relation between these two, correct?
Yes, sir.
What is the ratio of these two? Ratio of these two.
0.92.
0.917.
Rounded 9 to correct?
Yes, sir.
Very good. Can you find out the MS for total?
3.64.
3.6428.
Is it fine?
Yes, sir.
Then what is the value 1 minus of MSC by MST? What is the value?
0.887.
0.887. Is it the same value when rounded?
Yes, sir.
Do you see
Yes,
the
sir.
same value here?
Yes, sir.
Yes, sir.
Good. Very good. So this is how these are related. Now coming to F value. How do you get F value? How do you get F value?
MSR by MSE.
Sir, MSR by
MS. Yes, sir.
MS regression by MS residual, MSE, correct?
Yes, sir.
Yes.
Yes, sir.
Okay. Just check whether 11.7 by 0.41, 28.4.
Yes, sir, it's correct.
Very
Sir,
good.
it's 28.5.
Okay, some rounding error will be there because this is software calculated and you are taking 11.7. Actually, it is 11.7177 something. And this is not 0.41. This is 0.41291 something. Okay. We always round and therefore we have error. Don't worry about it. You understood how do you get F value.
Yes,
And
sir.
the level of significance is 0.001, the p value. The p value is compared with alpha. What is alpha? Is it given in the problem?
No, sir.
If it is not given, what you take?
0.05.
0.0.
Okay. Now, by comparing the p value with alpha, what conclusion you give?
Reject H naught, sir, because p values is smaller than. No, accept. I don't know.
Do you reject H naught or accept H naught? Do you reject or accept H naught?
Sir, can you again repeat the scenario?
This is the p value and this is the alpha value. Comparing these two, what is your conclusion? Is my question.
Well, reject H naught.
Reject H naught.
Sir, reject.
Reject H naught.
Reject.
Reject H naught is the conclusion. Reject H naught. Very good. Then what is a H naught?
Model is insignificant.
Yes, sir. Beta 1 is
Uh,
equal to 0.
Normally we write in symbols. If you write in symbols, how do you write this? Beta 1.
Beta
So beta 1 equal to 0.
equals to
You
0.
say beta 1 only, not beta naught. Okay, beta naught is something different. It is intercept.
Yes, sir.
That is a different hypothesis. Beta 1 equal to beta 2 equal to
0.
correct. Then what is the alternative hypothesis for this?
Beta 1 equals to beta 2 not equals to 0.
The complement of this is both must be zeros.
No, sir. Either.
No,
Then what is alternative?
both should
Anyone
not be
can be a
zeros.
non-zero. Anyone.
Exactly. Any one. So can I write at least one beta is
Not equal.
not zero? Not zero. At least one beta is not zero. Can I? Is it a possible thing? Is it correct or not? This is very important. Think and tell. Is it right or not? At least one
Yes,
beta
sir.
should be
Yes, sir. It
not
is.
zero. At least one beta is not zero.
Yes, sir. Correct.
Yes, sir.
Okay. If one of them is not zero, then your H naught is wrong.
Significant.
Okay. Now, if at least one of them is not zero, then either beta 1 remains in the equation or beta 2 remains in the equation or both of them also can be there in the equation. Is it right?
Yes, sir.
Okay, fine. In that case, what is your conclusion here?
The model is significant.
The model is significant. Good. The model is significant. That means there is at least one beta not zero. Correct?
Yes, sir.
Very good. Now to answer this question, which beta is not 0? I want you to answer this question. Which beta is not 0? Can you answer? Which beta is not 0?
No, sir.
No, can you answer?
No, sir.
Array, this is very disturbing. I remove these two columns. If you want to know which beta is 0, what you need to do? If you want to know which beta is 0, what you need to do? Logic. Come on, come on. If you want to know which beta is 0, what you need to do? Hmm? Are you thinking or not able to get what I'm asking you?
Thinking.
Okay, tell.
No idea.
Any one of you?
No, sir.
Then what is the use of this table? Where can you use this table? Hmm. First of all, can you write the model from this table? What is beta naught value?
$83.23.
Very good. Okay. Next, what is beta 1 value?
2.29.
Good. Then what is beta 2 value?
1.3.
1.3.
Okay. And you got the model. Now, what is the standard of beta? Beta naught.
1.57.
1.57. Now answer my question. Um, okay, use calculator and tell me what is the ratio of these two numbers.
$52.88.
Is it the same answer?
Yes, sir.
What is the ratio of these two?
7.63.
There is some rounding issue. Maybe you are getting like that, but it is 7.53. Is it right?
Yes, sir.
Good. What about print add ratio?
4.
Is it not the same answer?
Yes, sir.
Okay. And by the way, do you remember how do we calculate the t value or anything? I will share another screen. Let me write the formula. Okay. In any testing of hypothesis, for example, the t-test statistic is equal to the estimated beta 1, that is estimated means cap, minus hypothetical beta 1 divided by standard error. Is not the general formula for anything?
Yes, sir.
Yes, sir.
Estimated beta 1 and hypothetical beta 1. Whatever you write here, that is called hypothetical beta 1, correct?
Yes, sir.
Okay. Uh, you please remember this. Let me share a different screen again, back to the Excel. Okay. So in that case, this is the actual calculated value. What is the estimated value? What is the under null hypothesis? What is expected? What do you write in general? What is hypothesis?
0.
Correct.
Beta
This is
equals
beta 1 equal to 0. Then is not 2.29 minus 0 is 2.29 only, that divided by standard error. Is it not
Yes, sir.
straight away the ratio of these two?
Yes, sir.
That is the reason I asked you to take simply ratio of these two. The reason is, in all these cases, the hypothesis assumes that that particular parameter is 0. Beta 1 equal to 0, beta 2 is equal to 0, it is another hypothesis. Or beta not equal to 0. That way, you every time you write in the null hypothesis, those values are zeros. Fine?
Yes, sir.
Good. For this particular t value, what is the p value? Yeah, tell me, what is the p value for this case to test this particular hypothesis? To test this hypothesis,
For 4.57.
actually this is after decimal 7 zeros and then this. After decimal 7 zeros, then this.
Nearly 0, sir.
Nearly 0, of course. Your p value is almost 0. Then tell me whether you accept H naught or reject H naught.
Reject.
You should not take that much time. You have to. In my childhood, now, if I do any mistake, my teacher used to ask me write 10 times. Like that, I don't give you punishment. You please write, go home and write down. If p value is less than alpha, reject H naught. If p value is less than alpha, reject H naught. If p value is less than alpha, reject H naught. 10 times you do it. Why do you pause? You have to answer this very fast. Blind rule. If p value is smaller than alpha, reject H naught. Now this p value is less than alpha, what do you do?
Reject H naught.
Reject H naught.
What about this p-value?
Reject H naught.
Reject.
Reject.
Reject H naught. What about this p-value?
Do not
Sir,
work.
again reject.
Reject or do not reject?
Sir, reject.
Reject.
Reject H naught. That means all these three betas are significant.
Yes, sir.
All these three betas are significant.
Yes, sir.
Yes, sir.
Okay,
Same.
that means all these three betas must be included in the model, correct?
Yes, sir.
Very good.
Yes,
So
sir.
this is the model. If I write every time error now, what is the value of the error, you people may ask me. That is the reason I don't want to write error there. But error is there. You understood my logic?
Yes, sir.
Okay. Now my question is, uh, now suppose this organization spends 4 crores on TV advertisement and 3 crores on print advertisement. Then answer my question. What is this value? Already you know about the model. Yeah, these are the values. Please calculate and tell me. These are the values. Tell me.
$96.29.
96.29.
96.29 is your answer. When 3 and 2.5, oh, why it's coming like this? Control Z. Is it 4.2 earlier? Or any error here?
Yes, sir. It's 4.2.
4.2 only, sir.
Okay, good. Okay. So this value is, what is the value you said?
96.29.
96.29.
Okay, fine. This value plus this value into this value plus this value into this value. Is it the same answer?
Yes, sir.
Okay. So this is the answer. This answer seems to be valid or not valid by looking at the above values.
Valid,
This
sir.
is the predicted
Valid.
value. This is a predicted value. Oh. Okay. 4 and 3 are the values given to you and 96.29 is the predicted value. Correct?
Yes, sir.
Good. Then any questions
No, sir.
in this? Any questions?
No, sir.
Do you understand them?
Yes, sir.
Yes, sir.
So then we have completed this regression. Multiple linear regression, we have done this. And we will discuss the assumptions and what else? We already done this hypothesis testing here. Okay, and we will discuss about heterogeneity and few more tests are there. Whether the errors follow normal distribution. Errors follow normal distribution, and whether there is heterogeneity or homoscedastic variance or heteroscedastic variance. Okay, these tests we will discuss in the next class. So that is next week, correct?
Yes, sir.
Okay. Any other questions?
No, sir.
Okay then.
Sir, can you please share this Excel sheet too?
Tejasvi, are you there?
Yes, sir, I'll share.
Already yesterday I shared you, no? Same file.
Yes,
Now you
sir.
can share.
Okay, sir.
Okay. Already shared to your CR, but I asked her to not share it because we have not discussed that problem. Now we discuss, she will share it. Right?
Yes, sir. Thank you, sir.
Okay. Happy Diwali then. Bye bye.
Thank you, sir.
Happy
Thank you,
Diwali.
sir.
Diwali, sir.
Thank you, sir.
Thank you,
Thank you,
Bye.
sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Bye.
Thank you, sir.